Hello everyone. In my previous video, measurement 1, we have seen physical quantity and its types. The one who missed my previous video can find the link in the description. In this video, let us see what are fundamental and derived quantities. Fundamental quantities. Let's see first of all what are fundamental quantities. Okay. Out of a large number of physical quantities which exist in nature, there are only few quantities which are independent of all other physical quantities, and they do not require help of any other physical quantities for their definition, right? Such quantities can be called as fundamental quantities. So what can we write definition as? The quantities which are independent of all other quantities. Of all other quantities, right? And do not require help of any other physical quantity. Are called fundamental quantities. Right? In simple terms, we can say the quantities which are independent, right, are called fundamental quantities. Now in SI system, there are 7 fundamental quantities. Let us see what are those fundamental quantities in SI system. And these fundamental quantities are also called as base quantities or absolute quantities. So in that, first one is mass, and the unit of this mass is kilogram, and the symbol of the unit is small k and small g. Second one is length. Its unit is meter and the symbol is small m. And third quantity is time. Unit is second. Symbol is small s. Fourth is temperature. Unit is Kelvin and symbol is capital K. Next is luminous intensity. Unit is candela. Symbol is CD. Next is electric current. Unit is ampere. Symbol is capital A. Last one is amount of substance. Unit is mole and symbol is MOL. So we can conclude there are 7 fundamental quantities in SI system. There are 7 fundamental quantities in SI system. Right? Mass, length, time, temperature, luminous intensity, electric current, and amount of substance. Now let us see what are derived quantities. So what are derived quantities? The quantities that can be obtained are dependent on fundamental quantities are called derived quantities. The quantities that can be derived from fundamental quantities. fundamental quantities are called derived quantities. Derived quantities. Let's see example of derived quantities. Area. Area is a derived quantity which is obtained from length. Right? The formula for area is length into breadth. Length is a fundamental quantity. Breadth is also length, which is a fundamental quantity. So we can call area as a derived quantity. Next is volume. Volume is length into breadth into height. Length is a fundamental quantity, that is length. Breadth is also a length, which is a fundamental quantity, and height is also a length, which is a fundamental quantity. So we can write this as L cube, and this area can be written as L square because length into length. Next example is speed. Speed is equals to distance upon time. Distance is nothing but length, and time is also a fundamental quantity. So speed is a derived quantity. Next example, density. Density is nothing but mass upon volume. Mass is a fundamental quantity. Again, volume is a derived quantity which is obtained from a fundamental quantity. So density is a derived quantity. Next, let us see fundamental units. Fundamental units. So what are fundamental units? The units of fundamental quantities. Fundamental quantities are called fundamental units. So what are the examples for fundamental units? Just now we have written some fundamental quantities in a tabular form. These units, kilogram, meter, second, Kelvin, candela, ampere, mole, all these units are fundamental units because these are the units of the fundamental quantities called mass, length, time, temperature, luminous intensity, electric current, and amount of substance. Now let us see derived units. Derived units. So what are derived units? The units of derived quantities. Derived quantities are called derived units. Derived units, right? In other way we can say fundamental units which are used to express derived physical quantities. Then they can be called as here what? Derived units. Let's take examples what we have taken for derived quantities. So area. Area is nothing but length into breadth. So here length is expressed in a SI system as meter. Breadth is expressed even in meters. So we can write this as meter square. So here meter square is a derived unit. When it comes to volume, length is expressed in meters in SI system, breadth is also in meters, height is also in meters. So we can write this as meter cube. So here meter cube is a derived unit. Next, speed. What is speed? Distance by time. Distance is measured in meters in SI system and time is measured in seconds. So we can write this as meters per second. Second to the negative power 1. This is a derived unit. Next, density. Mass in SI system measured in kilogram. Volume is measured in meter cube. We can represent it as kilogram meter to the -3. So this is what? A derived unit. All these are derived units. Meter square, meter cube, meter second to the -1, kilogram meter to the -3. All these are derived units because these are the units of derived quantities. Let's see system of units. System of units. A complete set of units, both fundamental and derived, for all kinds of physical quantities is called system of units. How can we say system of units? A complete set of units. A complete set of units, both fundamental, and derived. For all kinds of physical quantities. Physical quantities is called system of units. System of units. The common systems are given in the table below, right? Fundamental quantities in SI system and their units. So first we have length. In MK system, it is measured in meters. Next, mass. In MK system, it is measured in kilograms. Next is time. In MK system, it is measured in seconds. When it comes to CGS system, length is measured in centimeters, mass is measured in gram, time is measured in seconds. And in FPS system, length is measured in foot, mass is measured in pound, time is measured in seconds. Time in all the four systems is measured in seconds. And in SI system, it is similar to MK system. SI system, International System of Units, which is similar to MK system. It includes 4 more fundamental units. What are those? One is unit of electricity, unit of magnetism, unit of heat, and unit of light. And what is the unit in electricity? That is electric current, which is measured in ampere, right? And heat, that is temperature, measured in Kelvin. And light, it's nothing but luminous intensity measured in candela. So these are some additional units that are included along with this 3 fundamental units in 3 different systems. Hope you have understood this video. Thank you.